Hello guys, welcome back to my channel. Hope you're doing well. I'm Ronak, your statistician friend, and I'm back with another video. In this tutorial, I'm going to run paired sample t-tests in our studio. We use this technique when we want to compare two means of two measurements, but from one sample. It's also called within subject design and repeated measures design. Imagine we have a sample data set of 12 60-year-old patients that their glycemia or blood glucose level were measured before and after a 2-week exercise program. So we have variables of their gender, their BMI, and their blood glucose level after and before the program. What is important to consider here is that we measured the same sample twice, once before the program and second after the program. In statistics, we call the program a treatment, and we measure a group of people that we give them a treatment and then we measure them again. So then if the scores in second test are higher than a pre-test, we know that the treatment had an effect, but we don't know if it's a positive effect or a negative one. So that's why we run the test. So go ahead and open an R script. First, we need to install this package, tidyverse, for data manipulation and visualization. If you haven't installed it yet, you do so by install.packages command. Then import your dataset using read.csv command. We have the same assumptions as we had for one sample t-test. And since we're working with the same data set, the assumptions are all met for previous variables. And as you may know, assumptions of paired sample t-test are no extreme outliers, no missing data, dependency of dependent variables, and normality of dependent variables. But now we have a new variable after treatment, glycemia level. So we will draw the charts for checking two of these assumptions, no outliers and normality, for after glycemia variable as well. So we need to run code that gives us the chart of QQ-plot. So we run it, and you see it checks the normality assumption because all the data are around the line of normality. And for checking outliers, we need to draw a box plot, run it, and you see we don't have any outliers. So we're good to go. Then we get a summary of our data set. You see, mean of glycemia before the treatment was 133.3, and the mean for glycemia after the program is 127.2. So probably there is something there. But let's run the test and see it better. So go ahead and run the paired sample t-test by t.test command. But this time around, we have two variables, before and after. And unlike one sample t-test that we were supposed to define the mu or mean of the population, this time we're going to have paired property that stands for paired sample t-test, and we put it equal with true. So run it and print the result. So here is the result in console window. You see the t-test statistic value is 2.3969. So go ahead and open up the t-student table and then look up critical t-value of 9 degree of freedom and significance level of 0.05. And there it is. And it is equal with 2.262. So you see that t-value is greater than the critical value, and it means that we reject the null hypothesis. By p-value, we will get the same result as well, because p-value is less than 0.05, so we reject the null hypothesis. And lastly, through confidence interval, if it does not cross 0, then we will reject the null hypothesis. You see the interval of 0.34 to 11.85 does not cross zero. Both lower and upper values are positive and are in the same side of zero. So we again reject the null hypothesis. So from these three findings, we conclude that our variables are statistically significantly different. And based on our research, it means that the exercise program did affect the blood glucose level or glycemia, and it has reduced it, meaning that the program affected the glycemia for the better. And that was it. That was the process of running paired sample t-tests in R. Thanks for watching this video. If you have any further questions about this test or any other test, you can ask me in the comment section below. And I'll see you in the next video.